thank you everybody for joining us. And just very quickly, the whole point of these sessions, and you're going to see them every week, is we're going to go and play with Neo4j Aura free. So for those of you, what's Neo4j Aura, what's Neo4j Aura free, don't worry, we're going to explain it to you in a second. But this is what we're going to be doing. So Necro is on GMT +3. Excellent. So it's a convenient time for you. It's currently 11 o'clock in the morning for N1. So getting a bit of distribution going on this. I think Necro and N1 are in the same location. Right.
Close enough,
Brilliant.
I think. Yeah.
I know. Yeah. Oh, close enough. Yeah, same time zone. Yeah. So very quickly, what do these Monday slots look like? What's the plan? So today, and obviously maybe for a couple of weeks and then we'll stop doing it. But for now, I'm going to give you a quick recap of what Neo4j Aura free is. We're then going to pick a data set. So I've taken the liberty of picking one this week. So this is going to be the basketball data set. So NBA, I think it's the National Basketball Association, USA. Randomly picked one. So I'm going to show you where I found that data set. We would love to explore your data sets. I know we've done this ad hoc in the past where someone's gone, hey, I've got this really cool data set. I think we had one with, do you remember, Alex, with retail, wasn't it? Where we stores and so we love those. Hi, Mandy. Thank you for joining us. So if you've got a cool data set, let us know. I know someone's suggesting a data set on recommendations of audio, so they're just trying to get that sorted. So that might be one. If you've got one, tweet us, let us know on Discord, shout it out, we'll grab them. Love to hear suggestions. So the only caveat is we need to be able to get that data easy. So we don't want to do any downloads. So if we can grab it from a GitHub repo or something like that, that's perfect. But if you've got a data set, let us know. We're then going to look at that data set and we are going to just explore it and figure out what questions we might ask. And then based on that data set, we're going to figure out what the data model is going to be. So good so far. We're going to use arrows for that. And then we're going to load that data up in Aura free and query it. Simple as, all good. So
simple as that, yeah.
Do you want to do some more shout outs, Alex? I think we've got a few more people joining in.
We got a few more people, yeah. We have Koji from Japan. So I'm very pleased that you are watching us instead of the Olympics. So that is good to see. Welcome, Koji. And I think
got Manab as well joining in.
Manab, so exactly. Hi, welcome, Manab.
So you've got a question on the lambdas. So can we park that question and we'll come back to you? Maybe not in this episode, but that's definitely something worth exploring. So we'll come back to you on Amazon lambdas there. But what you'll probably do is, if I recall off the top of my head, you do have the Neo4j drivers, official drivers. So we've got Python driver, and I think Python's commonly used for lambdas. So you could probably do something there as well. And I know it's not directly related to the lambdas, but my colleague, Will Lyon, or our colleague, Will Lyon, has very recently put together a very cool blog post on how you can use GitHub Actions to scrape data as well. So if that's something you're looking at, so a plethora of things. So hold that thought and we'll get back to you on that.
Exactly.
Cool.
I think that is we might do a special episode on the thing.
Yeah.
Necroduck asks, and I think that's a good question for the datasets. Does it have to be in Cypher? No, it can be any dataset. Ideally, it's a CSV file.
Yeah. So for now, if we can stick to CSV, I think there's a little problem at the moment with loading JSON data. So for now, let's stick with CSV would be perfect. And I'm going to have a little poke around what are the tools we've got in Apox. I think we've got like an HTML loader as well and an XML loader. So I think as we go along, we're going to have a bit of fun with this. So for now, if you could suggest some CSV data, or if you give us ahead of time, a bit of notice, then we can have a look at the other ones and we'll see what we can do to wrangle it and get it up into Aura. But yeah, it's all good. And yeah, so Mandy's in Paris, so that's 10 o'clock local time there as well in the morning. Right, let's go because we've only got 50 minutes left. We're going to try and make these snappish. So we've talked about what the plan is. So very quickly, what is Neo4j Aura?
Shall we play that video, Lou? Or shouldn't we?
Oh,
we have a video.
If we quickly shoot through this, and then next time we do the video, I think.
That's the next time. Okay, let's do that. Yep.
So it's a database as a service, so it's up in the cloud, so you don't have to download Neo4j, you don't have to install it, it's all available there. It's a managed service with elasticity, so you can make it as big or as small as you need your instance to be. And it's managed infrastructure, so it's a managed graph database, so Aura will keep up to date with the latest versions of Neo4j. It will manage your backups for you. It will provide continuous uptime, oversee monitoring, all of that good stuff you would expect with database as a service. And you can go off and have a look. So here's a link here to get to the landing page. So that's dev.neo4j.com/Aura. So what's
sorry, Lou. If you type in Twitch, at least the Twitch folks, if you type !Aura, you also get that link ready for you. And I just did that. So if you want to go and dive in right away, you can do that.
Yes. Yeah. So Aura free, slightly different. So again, still Neo4j as a database, a cloud service, but it's a free version of Neo4j Aura. So it has some limitations. So for example, you're limited to 50,000 nodes and 175,000 relationships, but you still have access to Neo4j Bloom and browser, and it is free forever. So this is a really great way to get started and have a play and build something in the cloud. So you have those options there available. And this is the whole point of these weekly series that Alex and I are going to be doing with you. We are going to be doing it on Aura free. So we're going to be looking at different data sets. So hopefully we're going to hit on something that you like and you enjoy working with, and you're going to be like, yes. So that's the goal.
And because we always use public available data sets, what we do now or in the coming weeks is basically possible for you to recreate and do the same at your own time, and spin up your own Aura free instance, import the data set you think is interesting, like for example the NBA set today or any other set, and do the same things we are doing now.
Absolutely. And we're going to get going. So we're going to be using a data set from a website called 538. So don't worry, we're going to post this link. But what I want to quickly do before we crack on, just because it takes a little bit of time. So I'm not going to do this, or we're not going to be doing this every week, but I just want to quickly show you what it looks like. So when you sign into Neo4j Aura, you will be greeted with this page. So you can sign in either with an email address, or you can use things like your Google authorization. So here I've gone in with Google authorization, and you'll have this screen. So if you've not got any databases set up, you'll have this screen. So I'm going to click on create database, and you can see here for database types, I've got one here that says Aura free. So I'm going to have the Aura free one. So I'm going to select that. I need to give it some detail. So I'm going to call it Discover Aura free. I'm going to click the create free DB button. So I just need to make a copy of the database password. So do make sure you make a copy of the generated passwords, because it will not save it for you, and then you have a little bit of a problem. So you can change the password later, but if you lose that password, you will have to get rid of your database and start again. So do make a copy. If you value what you've put in your database, make a copy of that password somewhere, or if you change the password, make a copy of that and put it in a safe place. So this is going to take a few minutes to load up. So now, whilst this is loading in the background, let's explore where we got this data from. So there's this place called 538. So I'll pop that in the chat. And they've got loads and loads of different data sets. So we were just having a quick scroll through, and I saw, NBA. So I had a quick look, and I thought, let's go for this. So next week, I'm going to let Alex dig out a data set.
Yeah.
Probably be gaming related, which is good.
Well, maybe, yeah.
So I decided that. And what's really nice about the 538 website is you've got the buttons here, and it will send you over to, I think if I click on one here, it gives you the information about it. And a lot of these have a link to a GitHub repo. So this is where I've got the historical NBA data set from. So let's give you this link as well.
That's what I put it in chat.
Oh, thank you. Look at that. Super organized, Alex's. So this is the data set. So let's have a quick look at what we've got in here. So we have got game order. So when were these games played? We've got a unique identifier. So this unique identifier is the date the match took place plus the code for the home stadium where the match took place. You've got leagues. Obviously, you've got a number of leagues of the NBA. Is copy. It'll probably make more sense when we go through the data and I'll show you what's going on there. So year, game, etc., etc. Team ID. This thing we're interested in. How many points the team scored. ELO. So for those of you who've not come across ELO before, so ELO is a rating system. So it was created by a Dr. ELO. There's also a band called ELO, but it's not the same thing. It's Electric Light Orchestra, that completely different thing. But maybe that could be a data set for another episode. So Dr. ELO came up with this rating system. So I'm very familiar with it because it's used a lot in chess, or a derivative of it is used in chess. And basically, it's a way of trying to score how strong a team is. And long story short, based on an outcome or result of something, you will then make an adjustment to a team's rating. You've got the opponent's team ID and so forth. So game location, all these really useful things. So this is the data. And if you click on the CSV, obviously you can't see it. So if we go to view raw, and this is the raw data. So if you would like, so you can either click on the view raw button or chuck that into the chat as well. So very quickly, this is our CSV, and this link here, this is what we can use to query our data. So let's have a look. Oh, it's still going. It's still creating our database. So let's dwell a bit more. We can do our data model whilst that's going on in the background. So very quickly, as we talked about here, this is our unique identifier. So as you can see, this will be ISO, so year, month, day for the match, plus the 3 code of the home venue where the match was played. And obviously we know it's all NBA. So I think that was the game ID. And then here you've got the year it was played, the date it was played.
Wow, okay, this goes back to 1946.
Oh yeah.
Yeah, all right. This is a big one.
Oh yeah. All the games. And then you've got
games.
the code, and then Huskies. So TRH is for the Huskies. I have no idea what the Huskies are based. I presume T refers to the country. It's a good way to get prepared for your quiz questions, pub quiz.
I would assume Huskies is some northern state in the United States, but I'm not. I mean, NBA. The only fact that I basically popped in today was by coincidence. Really, is that the U.S. Olympics team lost for the first time in 17 years yesterday, I think, in the Olympics. So this is the only related NBA fact I can now share with you guys. But I mean, that's about it.
Oh man. But yeah, if you got that. So we talked very quickly. So this is going to be relevant. So you got this thing is year copy. So it's this flag here. Do you see where it says 0 and it says 1? So that's just to say that it's a copy. And what you'll see is we have a switch around. So just bear with us on this. So here you can see this is the same. So we've got the same ID. Same this, everything's the same. So the only difference here is the perspective of the team. So here, so we know that the Huskies were the home team because you got that TRH, and you'll see a flag here that says it was a home match. So do you remember we had game location? That's the game location. So that's a home match. So this is in the perspective of the Huskies. So here they had, I think this was the points one, wasn't it? So they scored 66 points and they lost. So you'll see like a result flag somewhere here. Game location, game result. So this is in. So that each row is in the perspective of the team being mentioned. So in the Huskies' perspective, they were playing at home and they lost. From the Knicks' perspective, they were playing away and they won. So this is copy. Just lets us know. So I guess this is all about how you're processing that data. So some perspectives, you may want to pull in both those roles. We might go down the route of we infer the result based on our data model. So that's our data. So let's see where we're going. Okay, that's still going. That's fine. We still have to do the data modeling, so it takes a few minutes for Aura to spin up, Aura 3 to spin up, so that's not a problem. So I guess, Alex, what kinds of questions would you like to ask of this data set? So we know what teams were playing, we know when they played, we know what the result was, we know how many points they scored, we know what their rating is. Do you have any thoughts on what you'd like to ask of the data?
Yeah, I think it probably would be interesting, who played against whom and what were the results. So like in this example, Huskies against Knicks, and then see maybe if possible, maybe even with a time timeline alongside of it, saying, okay, Huskies played the Knicks, I don't know, 15 times, and they lost, and then we can see how many times they lost, how many times they won when they played, two teams against each other over the iterations of the seasons. Yeah, that's the word.
Sounds good. Yeah. By all means, those of you watching, if you've got some questions you'd like to ask this data, pop them in the chat. Love to know.
Yeah, let us know.
Yeah. So for me, absolutely, I'd love to know the historical matches and all that kind of thing. I think for me, I would like to know the range. So we've got that ELO rating. So the geek in me is like going, I want to know which team had the biggest improvement or biggest variance between lowest ELO rating and highest ELO rating. So that's something I would quite like to know.
So that would be like a progress from the team. So
yeah, so I think there's two, isn't there? So one is like progress over time. How does the ELO change over time or over matches? Mm-hmm. But the other one as well for me to know is just is there like an absolute minimum ELO rating that someone's had and a maximum, or what's the variance like? Have we got like a big variance? So I know, for example, in chess, having a variance of more than 200, 300 ELO is, that's like significant improvement. So that'd be quite interesting to see. Oh, we've got some other questions coming in. Oh, Rabbitix has just joined us. Welcome, welcome. If you've got any questions about NBA stuff, chuck them in. So anyone's asked, what is the success probability of guessing relying on past experience for each match? Ooh. Okay, so using past experience. I guess that kind of fits in with the ELO one. We'll have to have a little tinker. I'm not sure. I might not be able to come off the hoof with a good answer for that, but I think that's a good catch-up question to come back with. But I like that one, everyone. So I'm just going to grab a copy of that and pop that in.
That is a good question. Yeah.
Excellent. So let's start building out that data model.
Don't place your bets on it, though.
Sorry?
Don't place any bets on it, though.
Yeah. This stream, do not be placing any sports bets on the basis of this stream. Nothing that we say.
Yeah.
Will not be held responsible.
No.
Okay, so I'm thinking. So I'm thinking team might be a good node here. Yeah.
Team is a good node.
Let's have a go. So let's do team.
I think you need to switch your tab. We're still in the.
Over.
Or maybe I'm.
No, it's showing.
Yeah, now it's here. Okay, perfect, cool.
I think it might be the great Twitch lag.
Maybe.
So code, and I've got a name because we had like Husky, and then it was TRH or something, wasn't it? So it got code and don't do that. Code and name. So we had a team, didn't we? Then the team played a match. Oh, Mike was hoping to make some quick cash. Sorry, Mike. Sorry to disappoint.
I mean, you can, but don't blame us if you don't make it and lose it.
I just got a match. And then what did we have? The match had an ID, didn't it? Oh, no.
It had an ID, yes. It was
ID.
Game ID, game_ID.
Yeah, it has a
year ID or not? Do we want a date game, basically? Yeah.
We'll stick to date. We'll keep it simple. We can always iterate and change it afterwards.
Yeah.
So it had an ID and it had a venue, didn't it? So where the match was played, so we could see if it was venue.
Yep.
And so we'll keep it simple for now. So this is a couple of things that I guess where it gets interesting. So let me just put this in for now, and then we can debate and figure out. So this has played in. I think this will work. This will work. So they played in a match, and then we had a bunch of properties, didn't we? And then we can debate if this is the right way to do it or not. So they played in a match. They had a score. They had a start elo, and they had an end elo. Okay, so we have something like this, don't we? So we have wanted to know about historical results. So we've got team playing a match. So we're probably going to have multiple. So we'll have the same team. We'll have lots of relationships coming out of team. Let's not just bashing my laptop. We won't worry about that too much. So we've got elo, so we can do like min and max elos. Probability of guessing results based on past experiences. There's lots of ways we can do that, but I think we've captured the information here to allow us to do that.
Do we want to add points?
Oh, points. Yeah, it's a score, I think. So that's how many points.
Oh, that's the score. That's the final result, basically.
Actually, let's call it points, actually. That's less confusing, isn't it? And then what we can do is we can infer the final result based on the points. So, for example, we say, because obviously you're going to have, you'll have two relationships coming into match. So there'll be the two teams going into match. And what we can do is we can do query where we compare the points, and that's going to let us know what the result was. So that's going to give us the results. It's going to give us the scores. We've got the ratings. We've got the team names. We've got the venue. What we don't have in that data set is location. So I assume there's more than one. Is there more than one team per state? Oh, goodness, I have no idea. Must be. Maybe.
Maybe there. I think there probably is, yeah.
Future episode where we can put in that data and do it. Okay, I think we've got, it's not perfect, but I think we've got a good enough data model now to answer those questions that we're looking at. So any other thoughts?
Benu Fire had a suggestion or a question rather. Played in will include home away as a property. Is it better just spotting into played home in, played away in?
Great question.
Figure out who was the home team.
Great question. So there are a couple of ways we can do this. So let's just quickly explore this one. So because we can do that, so we can figure out which one was the home match by seeing whether the team name matches the venue, or team code matches the venue. So that's one way of telling us whether whether they played home or away. The other thing we can do, which is what Bennu is mentioning, is what we could do is we could do something like, actually no, get rid of this, get rid of that. We could do this, couldn't we? So we could do, and then this becomes played in home, or played home, played away. We can pick the semantics, and then this one could be played in away. We can do something like that, and then we have the same properties. There are pros and cons for doing this. So the pro for doing it this way is that if I do this, does it make it bigger? No, it doesn't. No. So the advantage of doing it like this is that we've got a quicker query, because we can now query by type. So we can like pull back the query where if I wanted to find out all of the teams that had all of the away matches for a particular team, we could do it like this, and then I just use the query. Another way I could do it in the previous way was if I check the venue to match the team code, that also does it. So you've got two options. So I'm going to suggest for now that we keep it as just played in, and I think it's choosing what's the friendliest thing. So the intent is that we are going to write up this stream as a blog post. So let me take a note of that, Bennu, and then we can that's something we can discuss about the modeling choices. So I'm going to propose for now, let's keep it simple. I'm going to get rid of this. I'm going to keep it to played in. I will show you how we can do the find all of the matches that were home matches or away matches in our query. So let me do a question, list out home away matches as a query. Okay, cool. Right-eo. Let's go. Are we ready? Yes, we are. Look, there we go. Our database is running. We've looked at our data set. We've thought about what questions we want to ask. We've put together a simple data model. Let's load some data. Oh, we've got a question from Mike about can we have constraints and relationships in Aura? So you can't. So if you mean, Mike, by locking down what relationship types you can use, I have to double check. I need to remind myself because I believe you can put constraints on node labels and what properties you attach to node label. Let me double check that for you, Mike. I will get back to you on that. Okay, so we've got our data model here. So let's load in some data. So very quickly, we're going to use load CSV. So let's open up browser. So do you remember when I said keep a copy of your password?
Yeah, don't forget that, because otherwise.
Hopefully, if you're joining along, you've pasted it somewhere sensible, or if you're really organised, you've put it into your password managing software. Yeah, hey.
Yeah, and we're in.
We are in. Right, I'll get rid of that. Okay, so let's have a look at the data in Aura. So we're not loading it yet to the database. We're just going to have a quick peek. So, ooh. And let's look at the first few rows. There we go. There's our data. Look at that.
Perfect.
Okay,
we see all the fields. We see it all filtered out in this slightly different, but basically the same information we just saw earlier in that CSV file now as a split here for the first 5 rows. So we see the Duskies game we looked at earlier.
Absolutely. So there we go. We've got data simple as. So we've used load CSV. We've not downloaded any data. We are just using that GitHub link. How cool is that? So we're in business. Nice with these public data sets. We can do that.
Yeah, that makes it much more easier.
Oh, I've just had a thought, Alex. You know what we need to do? You know, you can use a Google form to collect data, and then you can get the CSV off the back of Google Sheets.
Yes. Yeah,
we need to do an episode where we do that. And we get everyone who's watching to put in some questions. And we can do that.
Yes, yeah, that's a good idea. We can have some open tags, and then we just everybody fills in, and then we have a small little Twitch viewer set we can then put in. Yeah, yes. That's a good idea.
Actually, I'm not going to bother putting any indexes in. This is quite a small data set. Should be fine. Well, famous last words. Let's see. All right, let's add some data in here. So we are going to create a team. So we're going to use merge. Another good reason for just keeping it as played in rather than played in away, played away, is I can just be really lazy with the stuff that I create now, because now what I can do, I don't have to differentiate between if it was an away team or a home team. I can use exactly the same as the create merge statement that I'm about to do, and I can just blindly dump it into the database. So it means I can be really lazy. There's one advantage to sticking with this data model for now. It'll all make sense in a second. So where are we? Here we go. So this allows Lju to be really lazy. Yay, lazy. So team, And what did we say? We said we've got code, and code was, what did we call it? We called it a team ID.
It's team ID, team underscore ID.
Yep, team. It's going to be row.team ID. So what's probably worth mentioning as well, what we want to do is with row where row dot, we said, was it duplicate, wasn't it? Is copy.
Is copy.
Equals 0. So the reason why we're doing this, so if you recall, you notice how we had these rows repeat and the IDs repeat, and we've got, and each row basically does it from the perspective of the home team and the perspective of the away team. So each one does the perspective of each team. So to allow me to maximize my laziness, I am only interested in the is copy is 0, and then I'm just going to do 2 merge statements, so one for each team, and then I'm going to hook them together. So maximum laziness here. So that's what I'm doing there. So we're going to do the home team. So let's do HT for home team. So code is that, and then it shouldn't matter, but we're going to practice, do good practice. So we're going to do on create, I think it is HT dot name is equal to HT equal to row dot fran ID. So what we're doing here is, what we're saying is it is good practice when you're doing merge that you don't put all of your properties in when you're doing a merge, because what merge does, it goes away, and if something doesn't exist in the database, it's going to go off and create it, and if it does exist, it behaves like a match. And as a result, merge does weird and wonderful things. So basically everything to the right of merge is treated like matching a pattern. So if everything's not exactly the same, it will go, it doesn't exist, and it goes off and creates a new one. So best practice is use your unique identifier for your merge. And then if you're creating something, then go off and do a bunch of things. If you want it to create, do a bunch of creates or things, if it's a match, then you can do on match and then do stuff. So this is good practice here, is to just merge in your unique identifier, then add any properties on the create. So that's what's happening here for our home team. And then we're going to do the same for our away team. Away team. And their code is row dot, what did we say? Their op ID.
Op ID, yeah.
Sweet. Okay, and then same idea, we're going to be good citizens. We only do the merge on the unique identifier, and then we're going to do away team dot name is equal to row dot opfran.
Yep. Underscore, yep.
Okay, right. Okay, so we've created our teams. Now we need to connect them to a match, don't we? So we're going to do a create a match. So that's going to be match. And because we're doing a create, we can dump all the properties in here, because create doesn't check to see whether something exists already. It just goes. So we can put all of our properties in there. I like to use these high-tech terms, you see. So in our match, we've got an ID, a date, and a venue. So very quickly, so we've got an ID. So where is it? So it's a game ID here. So remember, we said we've got the date and the code. So the sharper-eyed amongst you may have spotted that we don't actually have a venue code in here. The only thing we've got is game location H. Now, if you remember, all of our is copy 0 always refers to the home team, home venue. So we can cheat slightly, and we're going to basically say that the row.team ID is our venue for the match. Hopefully that makes sense. If it doesn't, give us a shout. Okay, so so we have the ID. So ID is going to be our row.game ID. Our venue, venue is going to be our row.team ID. And what else did we have in here? Date. So our date is in
date
here.
_game. Yeah.
Thank you very much. So we will need to do something to the date, but we'll show you how we do that afterwards. We'll do the processing later. So the date is going to be, as you said, Alex, it's row.date game, and notice it is month, day, year. Just in case, yeah, that's the US way. So what we could do as well is we could cheat and pull out this. Another cheat we could have done, actually, let's do the proper way for doing the venue. So we've got the date. So I said that we could pull the date from the home team, but the other thing we could have done as well is we could do a bit of string manipulation. And what we can say is we can say the venue comes from the game ID. So if I do write row.game, what happened there? Game ID 3. So what write does, write is a string function, and it basically says, give me the n number of characters from the right-hand side of the string. So here, it's going to take the 3. So again, 3. It's going to pull the 3 right characters from game ID, which is going to give us the venue. So that's the other way of doing it. It's the same as the home team, but we do it like that, and then in case something strange happens, it's all good. So that's creating our game. And then we want to hook all of that together. So if I'm just going to do a with home team, away team, and the match. We're then going to connect them all together.
Do we need the score? Or is that in the, where did we put that? Sorry, I think we put that in the relationship. Yeah, never mind. That is coming.
Yeah, it's coming. It's coming. Yeah. Oh, and row. Good point. I need to remember row. So let's do, we'll be good citizens here. So let's do row dot. Did we say, is it score, isn't it? An op score. Oh, and elo and all sorts. Right, let's do this. So we're just going to pull out bits so that we're a bit more efficient with memory. So we want, it's points, isn't it? So we said points. So row dot puts as home points. Row dot, is it op puts? I believe it is.
Let me quickly check. Yeah, op underscore points.
Oh, excellent. And then we've got a bunch of velos as well, don't we? Oh, this is going to be so many lines. I apologize in advance. So we have got row dot. Let's start with the home elos. So elo I think is initial. I mean, you can tell because the n is like what was afterwards. So elo I is going to be home start elo, row dot elo n is equal to home and elo, and then I think we just add op in front of everything, don't we? Row dot op.
Yeah, exactly.
Elo.
Op underscore elo underscore I and op underscore elo underscore n. Yeah.
Thank you very much. So that's going to be away start elo. Oh, excellent. That should be as elo as away start elo. So let's quickly do these. Otherwise, it's going to complain as away start elo row dot op elo underscore n as away end elo. Okay, we've got everything we now need here for our relationships. Hopefully, it's fine. We can always correct the query if it all goes horribly wrong, and we may need to put some indexes in, but we'll do that in a bit. We'll test to see what happens. It doesn't hurt to throw out a few errors. Keeps it exciting, doesn't it? Right, so we've got create home team. And they played a match, didn't they? So they played in, and we can now put in our information here. So we had points, which will be home points. We have got start elo, which is going to be our home start elo, and we had an end elo, which is going to be our home end elo. So they played in the match, and then we go the other way around. Actually, look, we can do it like this, can't we? We can click see what's going on. We can put the other side of that pattern, which will be this, and I'm just going to horrifically cheat and just replace H with A. What could possibly ever go wrong with a copy paste like this? Absolutely nothing. Flawless.
We'll see.
Flawless. Right. We're all now going to cross our fingers and hope that this works. Here goes nothing.
Oh,
No. Fell at the first hurdle. It's all good. It's all good. Right, what did we do wrong? Valid input HT. Expected set. Yep. I forgot the set. So set is what we do for setting properties. So my bad. On create set, and that sets new properties. Okay. Cool. Oh, I forgot to remove my return. Apart from that, we're perfect. Hey, right, hopefully. So something to bear in mind with Aura 3 is it does have a very small allocated memory in CSV. So, okay, no, so I've put something wrong here because it says no changes and no record. So I've done a boo-boo somewhere here. So let me have a look where I've done this. I'm just going to grab that and let's do return row limit 5.
Oh, okay.
It's a string. It's a string. Hey, okay, there we go. Right, so let's go back to our previous query. So something to bear in mind. Actually, we can get rid of this, can't we? Just make do a bit of tidy up. So something for you all to bear in mind is that all of this is coming back as a string. So sometimes I've put in here as an integer, but actually this is being recorded as a string. So we'll show you how to change the type of properties in a second. So that'll be useful when we're doing the points. But for now, let's load that data. Okay, I think
looks good.
It looks good. Hopefully, it's all going to work well. So we'll give that a little while. It shouldn't take too long. It would have been a bit faster if I. Ooh. Oh dear.
Oh.
Oh no! There's too many nodes.
Well, we can limit that, I guess.
We can. So let me see what we can. Let's just quickly, because I did have a quick peek earlier and I thought we were okay with this. So merging the home team on the ID. We're beating cat videos. I'm so happy.
Yeah. Thank you, Mike.
Oh, I love it. I love it. All right, let's just do quick. Let's just quickly see how many. I know this is perhaps not the best way to do number counts, but hey, it's fun. How many rows do we actually have here? I'm intrigued. So I'm just going to do return count start. So what this is going to do is it's going to tell us how many match nodes we've got in this data set. Survey says, okay, there we go. It was the match nodes. I can't believe that there's 63,000 match nodes in there. That's insane, actually.
Yeah, well, it's if you look at it from 1946 till 2015, yeah, it's. Yeah,
look, there you go, 63. Okay, so that was scuppering us. So how do we want to do this? Do we want to do the first? Let's do historical matches. Yeah, forget about the modern era. We don't care about the modern era. So what we're going to do Some people care about the modern era of basketball, I'm sure. Okay, so let's do this. So what we're going to do is we're going to put in another where clause here. So let's do it like this. So let's do and. How do we want to do this?
Should we limit to a certain year? Up until, I don't know, 1980 or something?
Oh, I like your thinking. Let's do that. Let's do that. So we need to do a bit of cheating in this. So let's just quickly remind ourselves of the data here. So do we have something we can... Oh, yes, we can do it on the year, can't we? We can intify the year. Mm-hmm. So let's go up to... let's keep it up to... If we go up to 2000, what happens? Do we breach 50,000 nodes by the time we hit 2000? Oh, perfect. Let's do that.
Oh, that works. That works.
Yeah, so up to so everything before the year 2000 sounds like a plan. So we're going to do, this is a little bit wasteful, but it's all good. So let's say to integer, or is it to int? I think it's to int, isn't it? And to int row dot, did we say year? So
that's actually a good question from N1. Why just not limit to 50,000? I mean, by putting a limit at the end of the query.
So we don't actually, if we could limit, I know, good point actually. So you know what, we can do that. It's not going to be perfect. I think it's going to end up with about 24 and a bitish, or 25,000 matches, which is fine for the purposes of that. So yeah, no, good that, because we do have a where clause here, so we could do a limit with our width. So let's do limits 50,000. Yeah, why not? I'm going to make it 49,000 because we've also got teams in there as well. Okay, let's do that. Let's do that. Good point. Well made. All right. Did it load some data to begin with? No, it did not. Okay, cool. All right. Let's do this. Oh. What did I put in there?
Oh, okay. Do we need an end between? No, it's not an end.
No, I think it's something about ordering. I'll probably have to put on this side. So, this way around. Someone in the chat's going to correct. There we go. Yeah, I put the limit in the wrong place.
Yeah, thanks. N1.
Oh, hey, look at that. We got some data in. Woo!
Woo!
Hey.
That worked.
Excellent. All right. So we haven't got huge numbers. So I think what's happening, because the limit applies to the first part, and remember we've got those duplicating rows, so maybe we could have doubled that and done it to 98,000. But you all get the idea. You can have a play. Right. Okay. We got us some data. So let's have a look at how much data you've got. So if we do match, yes, the video you'll be able to watch this video. I think it goes straight to YouTube after we're done, doesn't it, Alex?
It should go straight into YouTube. Yeah, you will be able to watch it basically whenever. Yeah.
So let's have a look at what we've got. So we've got labels, N, and count star. So this is going to tell us what we've got in here. So you can see we've got 87 teams in our data, and we have got 24,500 matches. So we've got some data in. You can see how many teams we've got. And if we do call, actually we haven't got any indexes set, so I'm going to bring this back in. Really? I can never remember. We'll find out. Is it going to give us a visualization? Oh, it does. Look, there we go. So there's our data model. Look at that. Team played in match. Right.
Exactly what we wanted.
Let's do this. Let's do some questions. So you wanted to, what was one of the questions? Historical results about Huskies and Knicks was one, wasn't it?
Yeah, that's an example. Exactly. Yeah.
All right.
Between two teams. Yeah.
Oh, between two teams. Yeah, that's it. So we can. I think we can find it here. So we know that's TRH for Huskies and NYK for Knicks. So let's do that. So let's find out some let's see what the rivalry was like. So very quickly, you know, I talked about the let's pull back some played in. So if you recall, we said that it's going to store things as strings. So it's not so obvious here about points and the elo being strings. But if I go to table, you will see that the points, you see they're being wrapped in strings. So it's not going to be easy for us to do comparison. So let's very quickly change those. Let's turn those into integers. So what we can do is we can do sets r dot points is equal to int r dot points. So that's going to set those as an integer, and then we can do the same with the elos. R dot start elo is equal to float. I think it's to float. It will complain at me if I've got the wrong one. Start elo, and you can see how very quickly we could have done this on the load, but we can also do it here as well. It's all good. And elo for those floats. R dot and elo, and that's going to go away and just integer. There we go. So that's just going to go away and just set them back to what we want. So let's check out these rivalries. So let's do match. We wanted to do Huskies and we wanted to do the Knicks. So let's match team 1, team. That's going to be
TRH.
TRH.
Yeah.
Thank you very much. And we're going to do team 2, team, code,
NYK. Yeah, NYK. Yeah.
New York Knicks. That's the level of my extended.
Yes, I think so.
And then it's going to be T1. If we do this, we'll start with this one to begin with. So let's do, and I'm just going to be really lazy and just do this. Super inefficient queries. So if we do T1 match T2, and then what we can do to begin with is we can return let's return the number of matches they've done. So let's do return count M. So this is going to tell us how many times they've, what did I? Let's do. Oh, I forgot to. Let's just do it like this.
I think it's now the comma after match. Maybe.
Yeah. All right, so they've played 6 times, so we can bring up those matches as well. So let's expand out this query. So let's do R1, R2. So what we can do here is let's expand this a little bit and just find out what happened. So if we do, so we know that T1, so let's say, what were the scores? So let's do T1 dot let's do name. Let's push the boat out. T2 dot name. Let's see what the scores were. So we can do R1 dot points, R2 dot points, and we can see where the venue was. So let's say M dot venue. Venue. So where did they play?
Mm-hmm.
There we go. So we can see.
Oh, cool.
Yeah. And let's expand this a little bit further. So what we could do is we can say, did the Huskies win against the Knicks? So what we can do, I think we can do just this. So we can do it's greater than that, and I think that should return a true or false. As hey, look at that! So now we can see how we're starting to build these things up, so you can see what happens.
Yeah, that's cool. Yeah.
So now then we can let's build on this a little bit more, And let's do how many times did the Huskies beat the Knicks? So we can do I think if we do count, just trying to think how to do this. We'll get. I'll have to have a little think about that. But anyway, you get the idea of doing that. So I think we've just hit the hour. So let's squeeze in a couple more queries. But you get the idea of how we're building this out.
Yeah.
How we can answer those questions. So I wanted to know about min-max elo rating. So this is a little bit more contrived, but let's do match T1 or just team. And just I'm just being really lazy here. I mean, you should put the relationship types in, but I'm just being lazy. So team played in a match. And then what I want to know is I want to know the team name. T.name with T.name min T dot R dot end elo we want. So that we said was end elo, wasn't it? As lowest elo and max R dot elo end elo as highest elo. And I think if we do return name, oops, sorry, my keyboard's being a bit funny. So with name, lowest elo, highest elo, diff elo is going to be the highest elo minus lowest elo as diff elo. So return name, lowest elo, highest elo, diff elo, order by diff elo descending. So what that's going to do is it's going to find out what was the minimum elo the team ever had, the maximum elo ever had, what's the difference between those two elo scores, and then I want to order the teams by the highest elo to the lowest elo. So hopefully this is going to work. Hey, there we go. So based on a limited data set, those are, so we've got the Sixers have had the biggest range difference between elo there. So that gives you an idea of like improvers. So obviously, there's lots of caveats here. We don't know how that's changed over time.
Exactly. I just wanted to say if we put in years, we would know when each score was. Yeah. But
this is an absolutely basic.
Yeah, absolutely.
Like sort cool. of crunch at that.
Yeah.
It's a bit fun.
We could. No, but yeah, we would need the year, so we would know. Depending on if the Sixers grew from 1160 to 7076, or if they actually dropped from 7076 to 1160, we don't know.
Very good point. So we can have a bit of a play of the year. So a fun one might be to see the biggest improvers. So that's one for we'll have a little think about what that query would look like. I can't, off the top of my head, I need a bit of thinking time. So let's squeeze one. Can we squeeze one more query in that we had?
I think we can for sure.
Let's have a look what we had. So list out home away matches. So yeah, let's do that. So very quickly, I know one question I think that was asked was the modelling decisions and how can we tell the matches are. So what we can do is let's take the Sixers, for example, and let's find out how we'd list out all of their home matches. So what we can do is if we do match, I'm just going to chuck it all out into one query. So let's do team, and we're going to let's go with name this time because we want the Sixers. I don't know what their code is. Let's do Sixers, Robin sizes. Sixers played in a match, didn't they? And that was in a match. And what we can say, where m.venue is equal to t.code. So this is going to pull back all of the home matches for the Sixers. And then what we can do now is let's find out who they played against. So let's do match T. Actually, let's do match M. And what we're going to do here is do T away. So that's going to be the team that they're playing. Oh, opponent team. Let's do that against their opponent. And that's team. And we're going to say where M is, sorry, op is not equal to our sixes. And then let's return some data. So let's return the home matches. So we know it's the Sixers. So they played against. So let's do op dot name as played against. And we can say what the played against. Do that. And if I put in with T M R, so played against the result. Let's do let's do R dot points. I think we concatenate with a plus. If not, it will get sworn at by the browser, so it's all good. Do my error checking with the browser. I think it's either plus or ampersand. I can never remember. We'll find out shortly. R2.points as score. Right, let's see what happens. There we go.
Nice.
There we go. So those are all of the home matches, and there's a lot of home matches there, but Sixers played a lot of home matches, didn't they? Ooh. That makes sense, actually. Yeah, because there's what we said, there was 87 teams, more or less, and then we still got what 50 odd years of matches, so 50 times 70. Yeah, it's right about the ballpark. So there we go. So we've got all of their. So there you go. These are all the people that they've played against, and what was the score. So let's add a little bit more in there. So let's put the date in there as well. So let's put in, whoops, m.date as date. So let's just expand that. Let's make it a bit prettified. So right, so obviously we need to sort by date here, but anyway, you get the idea. So that's where we can have a look at the various home matches that the Sixers have played and what the score was. So I think we're a little bit over our prediction on every game of the previous game. So anyone, a brilliant question, really, really useful question. Let us have a think about that, and maybe we do an MBA part 2 where we come back and answer some of those questions, or we will follow it up in the blog post. So absolutely, there's real value around that. And I know Mark Needham put together a blog post on the greatest of all time on tennis players, so maybe we can steal some queries from there. We can also have a look at that, and we can, because the thing is, there's lots of things here, because maybe we can do things like historical, like how did somebody do when they played against teams in the past? You know, is there a trend there? Is there a factor of their ELO rating? So does their ELO predict how likely they are to win? So let us have a little think about that offline, and we'll come back with response on that. But other than that, wait, we had some fun, did we not?
We had some fun, yeah. That's a cool data set. I think that is, with the historic matches and the insights, it's good fun. And fairly, and like you also, fairly easy to explore, fairly easy to start things with the Neo4j graph database on Aura. So, you know, everybody can do it.
Have a go. Have a go. You've got all the links there. We'll update this video description for those of you who are watching this or going to be watching this again. We'll update all the various links in the description. So don't worry, you don't have to be sitting there trying to type them out. And have a play. And hopefully, Mike, we're still more drama than cat video. And we'll be back next week.
We will be back next week. Have a good week, you all, and hope to see you next time. Thank you for joining today.
Thank you for joining. Have fun with Aura Free. Let us know what you get up to, and we'll see you all later.
Exactly. Take care. Bye-bye.